So this is to continue talking about the CART models, classification and regression trees. In this recording, we will be focusing on the classification trees. So the classification tree is a decision tree when the outcome variable is categorical. Its recursive partitioning process splits the cases into pure subsets. And we will be focusing on one idea, which is the target variable has to be binary. And subset is pure when it contains cases that all belong to the same classes or to the same class. And the highest degree of impurity is 50-50, 50%, 50%. And the highest degree of purity is going to be when we have zero, as we said. I mean, the pure subset, when all cases belongs to only one class. The impurity measure we are going to use, which is Gini in this course, impurity is measured by how well the two classes are separated, and we need to identify possible split points. The CART algorithm uses the midpoints between the consecutive values if you have a numeric predictor variable. Again, if you have a numeric predictor variable, we use the midpoint. But if you have categorical variable, you are using the grouping, class grouping. Then we identify the optimal partition that minimizes the impurity in the two resulting subsets. Let's look at the example. So in the introductory case that we talked about, we have, if you remember the predictor variables, we have the sex, age, and income. The target variable was whether the person or the customer is going to respond yes, which is number 1, or no, which is 0 to the offer, right? So we have basically, if you look at the predictor variables, we have income and age. So the split points, so for the income is going to be the middle point between the two consecutive values. For instance, these are the values for the income. So how to split the possible split points is between the 4,000 and 11,000 is just you add these two, you divide by 2. So we get this, the split points. So if you use a split point of 64,500, how pure would the resulting leaf nodes would be? This is maybe one of the questions that we may pose. So let's look at this is the Gini impurity index. The Gini impurity index has it's going to have a range between 0 and 0.5. The goal is to get the lowest Gini index. The lowest Gini index tells you that this is the lowest impurity or the highest purity. The opposite way around. If the Gini index get to the highest value, which is 0.5, so that means you have the highest impurity. The Gini index measures the degree of impurity of a set of cases in a multi-class classification context, and is the one that we are going to use to determine the optimal split at each step. So the optimal split, where we are going to split, which variable we are going to split, which one is going to be my root node, is it the age or the income or the sex? So this will be done using Gini index. We will not do any manual calculations, just we will give an overview about this. So this is the point of the Gini index. For instance, if you go back to this simple example that we have, suppose that Hayden selected 20 random observations out of the 500 that he has, right? And he found out that these one on the red spots the ones who responded, but the other ones who did not respond to the offer from the data that he has. Suppose this is my training data. So we just picked 20 out of 500 as a training data to build the tree. So he would like to decide which variable is going to be the top node, the root node, which one who's going to decide first. Is it the age or the income? So what did he do? He first, without any splitting, he just calculated the Gini index, and he found that the Gini index is 0.37. This is without any splitting. If you just do nothing, what is the Gini index? The impurity index is 75% to 25% split. So if you look at them, we have about 15 of the people said no, they will not respond, and 5 they will respond. So if someone comes to you, or if you want to check a case, then you will say that, hey, this person is not going to respond without doing anything, because the majority here is the people who did not respond. But now what he did, he computed the Gini index for the age, and he found that the split value has to be 49. So if the person is he's older than 49 years old, then most probably he's going to respond, because you have 3 dots of responding, 1 is not responding. If the person is less than 49 years old, then most probably the person is not going to respond to the offer, right? So how did he find that? He calculated the Gini index, and he got that the Gini index is 25%, 0.25, which is the impurity index. Remember, without doing anything, the impurity index was 37%. Now, with doing this split, the impurity index is getting lower, and the goal is to get lower Gini index. It's 25%, which is better than the previous one. So if we want to do something, it's good to have a split at this age, 49 years old. So at least we have something now. If you want to classify a record, so just you want to look at his age, based on the age only, then you can tell if he's greater than 49, if he's older than 49 years old, then you can tell that, oh, this person is going to respond. If he's younger, then he will not respond. But we have to look at the other variables as well. What about the income? What if we split based on the income? And he found that the split value is $64,500. Is it going to be better Gini index or lower? Actually, we got 27%. So we have the age 25% or 0.25, and this is 0.27, which is higher than the 0.25. So if I want to start with any variable, it's going to be the age. The age is going to be my root node, not the income. And the split is going to be at 49. So this is my root. So based on this, we can tell the root node is going to be my age. So it's going to be my age. So the process is going to be repeated. So for instance, this is my first split. Then we're going to go to the right. Then we're going to look again to the age and the income. What is the best Gini index? Do I need to split vertically or horizontally? We found out, no, you have to split horizontally at this income, which is about 40 something or less than 40,000. So if a person is older than 49 years old and his income is less than 39,000, then he's not going to respond. But if his income is greater than 39,000, he's going to respond. Then we have another splits here. So all of these splits have been done using Gini index, the lowest. Then we come up with this full-grown tree, which is the age. If the age is greater than 49, we're going to go to the right. Then the other split is going to be the income. If the age is less than 49, the other split is going to be still the age. We have to do another split for the age, and this is clear from here. It's 23.5. Then the other split is going to occur in the income until we get to the pure. So we keep doing this until what? No longer produce a lower Gini index. This is the lowest Gini index. Or when all the partitions becomes a pure subsets. Pure just belongs to one of the class, like this one. This is a pure. This is a pure, right? So we'll not respond here, we'll respond, and so on. So these are terminals. The green ones are terminal nodes. So the large data set with many predictor variables will likely generate a very complex tree. And this is true. As the number of the partitions increases, the misclassification rate for the training data will decrease eventually to 0. And for a new dataset validation, the misclassification rate at the beginning will decrease, but after that it's going to increase after a certain point, because we will have a problem with the overfitting. That's why we need to do the pruning. So the pruning is important to optimize the complexity of the final decision. And the simple approach to prune the tree is just to reduce the misclassification rate in the validation data by what? Replacing the branch of the tree with a leaf node. For instance, look at this tree. We can just eliminate the whole thing, the whole branch here, and we can decide that if the age is less than 49, the person is not going to respond. Look at this. Because look, the majority of these cases are blue, so we can decide, oh, it's just clear that less than 49, so the person is not going to respond without considering these, two red dots, right? So we can just immediately come up with this. So this is a pruned tree. We eliminated many of the nodes, interior nodes, to come up with this. So we can actually come up with these decisions at the end. So this is the optimized tree. If the age is less than 49, then the customer will not respond. If the age is greater than or equal 49 and income is less than 39,500, then the customer will not respond. But if the income is greater than 39,500, then the customer will respond. So this is the about classification trees, and we are going to do an example on R to see what's going to happen. After that, we'll be talking about regression trees or the predictive trees.